Welcome everyone to this talk about microservices, patterns, and anti-patterns. It's kind of a brave thing to talk about at a conference that is exclusively about microservices. If I do something like this at a conference that's not only about microservices, assuming there are such conferences anymore, then there will be a number of people who don't know anything, and they will get some value out of some introductory stuff that I do. I'm not planning on doing that today, and so the risk is that I'll talk about some anti-patterns that you consider patterns, or the other way around. We'll see. So my goal is to talk about words. That's actually what a talk about patterns is about, right? A patterns talk is about giving names to things. And that's actually something that I like to do because it's a good excuse for coming up with a topic, and it also helps me talk about things to my colleagues, to clients, to people in the industry, to people at conferences. And I like this idea of having a shared vocabulary where you can talk about things with common names. So that's what we're going to talk about. Talk about some patterns and some anti-patterns. For the patterns, I've chosen a very, very simple format, so I'm not providing you with a pattern language of some kind. It's not formalized. You might argue maybe not everything qualifies as a pattern, but I don't really care. So I'll just go about it and have the same format everywhere. So a pattern always has some sort of description, and it has something about the approach. So how do you go about this? What do you do if you apply this pattern? And what are some of the consequences if you do so? So to make this a little less theoretical, let's start with a first pattern. It's called microservices. You might have heard of it. So a microservice is something that, of course, as any hype, can be defined in many different ways. This is the way many of my colleagues like to define it. The idea here is that we design modules in a way that they are separated from each other, and something that used to be an implementation detail becomes some very important aspect of your software architecture, right? So we do this to get more degrees of freedom for our implementation so that we can do different things, right? So technical deployment architecture becomes something that you very explicitly do as part of designing your system, right? Network communication gives you a boundary between those things, so it isn't as easy as it used to be to violate those rules. You build those modules, and you don't just have to do the right thing. You actually are sort of encouraged to do the right thing because it's harder to do the wrong thing, to cross the boundary, right? It makes it a little hard. At least it should. And you can have some consequences arising from this, which are blah, blah, blah. I'm not going to go over all of that because you all know that, and you believe it, otherwise you wouldn't be here, right? Okay, so now what you can see here is that the way that I've chosen to phrase this is my specific view on the thing, right? So you might have a different view on what a microservice is. And in fact, I'm going to be talking about some different kinds of microservices, specifically based around the size of microservices, which I think is a very important distinction. So I've given different names to different sizes of them. And you can also see my personal priorities in this, right? So I like to make this very explicit. You could argue that essentially if we just did things the right way, then we wouldn't need microservices with this definition, right? If we just all built modular software, everything would be fine. But we don't, so we need microservices. At least that's my view. Now, that is an example of a very technical pattern, or well, a somewhat technical pattern at this particular level. We're talking about this architectural thing. We can also raise the level, I'll only do this once, to a different level. This would be something like evolutionary architecture, right? This is now something it's more general. It's a generalization of the microservices pattern. You could have lots of different things that qualify as maybe having an evolutionary architecture. So what this means is you actually don't try to come up with an architecture that's the right one. Try to come up with an architecture that can always be changed to be the right one at that particular point in time. So you build evolution into your decisions, or evolutability. I don't think that's a word, but it should be, right? So we have the possibility to evolve it and to move it forward. Now, to do that, we probably have to separate things in some way and give us this chance of changing things independently from each other. So we have those islands of change. Maybe we design so that we can easily replace something as opposed to having a focus on reuse. This sounds suspiciously like microservices, right? But you don't necessarily have to do something like microservices to do this. You can do it in a more general fashion. We try to minimize shared dependencies. We sort of put the lever in a different position, put the have the pendulum swing in the other extreme to say, well, reuse is not the most important thing, efficiency is not the most important thing, it's rather autonomy, redundancy, and the idea that we don't share so much that it slows us down. And you can think of this as something like the cells that a body is composed of, right? We all are the same person that we were 15 years ago to a certain degree. I mean, we're not. We're still the same individual, but we have changed, but we still are the same person. So that's kind of the feeling that we want to have for our systems as well. They should be able to evolve. They will change over the course of time. None of the cells will be the same. None of the individual parts will be the same. Maybe not a single line of code is the same, but it's still the same system, because if it weren't, you'd have replaced it in some sort of Big Bang operation, which is something that we all want to avoid. So those are just two examples of patterns, right? And of course I have antipatterns as well. Antipatterns follow a very similar format. Now they have some sort of description. There is a reason for why I believe this happens. It's not the reason for why it's an antipattern, it's more a reason why this occurs. Why, if it's an antipattern, do people end up doing it? It's not an obvious thing sometimes. And of course it has some consequences. Those are all the bad things that are the result of having this antipattern occur. Now, a good example of an antipattern is a microservice, so I'm going to call it microservices gone bad, right? That would be the dreaded distributed monolith, where essentially you go to a conference and everybody tells you the microservices are awesome, and then you go back home and you build something and you turn it into microservices and it ends up being something bad. That is known to happen. Now, to paint this in the most negative light that I can, right, you just come up with some arbitrary mode of slicing things into smaller parts, and you just put them together somehow, and you end up with this giant mess of things that is just combines all the bad things from all the different approaches that you know, right? So it's a distributed monolith, the worst kind. You could call it hype-driven architecture or conference-driven architecture. Again, it's not something that any of us would do, right? But all the others going to the conferences end up doing that. Typically, you end up not caring too much about the business domain. This is rather the situation where you end up doing it for the sake of doing it, right? Because it's kind of cool to build something using microservices, so you end up doing it. This always goes hand in hand with getting lots of infrastructure components that don't serve any business value, but rather give you technical solutions for problems you wouldn't have if you didn't, whatever, right? So that's kind of a sign, this massive over-engineering that you see where people invest in dynamic rebalancing, registry, dynamic component, load balancing, proxy, equalizer things, whatever, and end up missing what the actual business domain is. Now, the consequences are obviously that you have this ripple effect of changes, right? You change something and you get all the negative sides of a distributed monolith. So if you change something here, something else falls over. You get this very, very complex environment where you now have lots of extra problems because you have all of this network overhead, both in terms of runtime overhead as well as thinking time overhead, development time overhead, because everything's now so absolutely complicated. You have, in the negative extreme, this wild mix of technologies that nobody can manage because everybody can do whatever they like. They do whatever they like and they have fun, but you don't, assuming you're the one tasked with maintaining the stuff, right? Again, sometimes you can see the same thing painted as a pattern and as an anti-pattern. That's something that I might do again. We'll see. So let's go into more detail and the level of detail that I want to talk about. So my first anti-pattern, I'm going to start with the negative things to leave you on a positive note at the end. So starting with the negative things, let's talk about this decoupling illusion. Now that's something that I've observed a number of times. People introduce microservices for a reason. Very often the reason is that they want to be more flexible and be more agile and be able to more quickly adapt to changes. So you split things into those smaller things because a small thing is better than a big thing, and I tend to agree as long as we're talking about software here. So you have different kinds of stakeholders, look at this thing, and now something interesting happens. You have some stakeholder, some business person who wants something, and for you as a developer or architect or designer to actually fulfill their need, you'll end up having to change something. It might be this, these few microservices that you'll have to change. And you can probably see where this is going to lead, because there's a second stakeholder who's involved in a different set of microservices, but there's some overlap between the two. It's just this one microservice that both are interested in. But still, you have to take care of the fact that both of them want something from the same microservice. So you'll end up having different needs for this particular thing. And of course, this can get worse if you have more stakeholders. So at some point in time, you'll find out that you haven't solved the fundamental problem that you want to solve in many occasions, which is you want to isolate the stakeholders. You don't want to come up with something that is small for the sake of being small. It doesn't help you if it's small and in its own module, if it can only be changed together with a number of other things that are also in their own modules, because you're fooling yourself. You just have one system. they all evolve at the same speed. You all release them at the same time. You have all the same problems. Well, you actually have some extra problems now because it's all distributed, right? So you've made your life worse in this particular model. I'm not going to go over all the textual descriptions. I've put them in so that you can read them afterwards if you want to. Essentially, the goal is that I always say what's on the next slide when I go to the picture slide, right? So this is sort of the description that I just gave. These are some of the reasons that you end up having this. Of course, it's very often because we're very much driven by interest in technology. I personally am very much driven by interest in technology, so I want to apply something that I've heard of and try it out. And it looks like it's a cool solution when everybody can build their own little service and doesn't have to care about others until they find out they have to care about others. Right, so consequences, I think I talked about that. Now, that is something that I'm going to come back to multiple times, this question of size and the granularity of your services, so bear that in mind. But there's also a different, you could say, orthogonal stakeholder aspect here, which is my second anti-pattern, which I like to call a micro-platform. Now, if you consider the different stakeholders involved in your architecture, there is another one involved. This maybe not that obvious. It's this one. Did you see that? There's a little gray box that just appeared in one of those. Anybody have a guess what that could be? Does this help at all? Right. So essentially, that's your magical platform. That's your supporting libraries. That's your runtime. That's your microservices stack. And it has its own stakeholder, which probably is your architect. And that's actually the person involved in everything now. Now, if you build something like that, then you have a stakeholder who is interested in every single service and who everybody has to sync with to do something, right? This might be because they provide you with this great little library that validates your authentication token, right? And they just assume that everybody uses that library, right? Because they have every right to do that. Well, if you reconsider, they've actually forced a technical dependency on you, and now if they update the library and expect everybody to run on the newest version of that library, everybody will have to update to that newest version as soon as it's required by the overall landscape, which is exactly the opposite of what many people associate with a microservices platform. Right, so you could argue that's a key anti-pattern. Don't have the same platform in every service, which probably tells you that things aren't as black and white as I like to paint them here, right? Again, you have the standardization of some runtime aspect, which, like many things, seems absolutely reasonable in the beginning of your project, right? Because otherwise everybody would end up inventing the same thing. Why would you do that, right? You want to reuse. Well, no, maybe you don't. At least be careful and give these things as options, as something that people can use if they want to, but not as something that they have to use and that you rely on them actually using. Right. So reasons. I think I've mentioned that. I've also included this little anti-pattern actually in a different slide deck. I have a whole set of slides on domain allergy, which is one of my favorite high-level anti-patterns, which is actually the fact that many of us like to play with tech and not so much with the actual domain. So we end up building stuff that's fun in a technical sense and then ends up polluting everybody else's code. But it's fun, so it's fine. Yeah, probably mentioned that. The bottleneck thing is kind of something that reoccurs all the time, and here it's something very, very explicitly associated with the development time, right? At development time, you have this particular bottleneck because now there is a single team or even a single person who's responsible for this particular library that everybody depends on, or this particular runtime platform, and now everybody has to go to them and expect to queue when they have a new feature that they want in that particular thing. Now that's one example. It's a very technical example, right? But there are also examples like that in the domain aspect of things. My favorite one is the entity service, right? So does anybody here have a service that's called the order service? Does anybody have an order? Well, you don't raise your hand, but I actually expect that half of you have an order service, right? Now, that sounds like such an obviously useful, reasonable thing to have if you're in any sort of retail application or any sort of logistics application, something that has something to do with orders, right? Because now everything can use or reuse that particular service. That seems to make so much sense. The problem now is that everybody who has a need of something in their particular service will actually enforce that need on that, will force their needs on the particular service. So it'll end up being a mixture of the interests, of the aspects of all its clients, of all its consumers. Now, sometimes that's exactly what you want. Very often it's not. Very often when you look at the thing, it actually shouldn't be there in the first place. Its only reason for existing is that the word order appeared in multiple different contexts. So that's just something that, well, let's just agree on what an order is, right? Older people will remember that as the, enterprise data model kind of thing that everybody agrees is a bad idea. So I suggest anytime you see something that smells like an entity service, take a very close look and decide whether it's actually something that you need, right? Because very often you find out that actually all of that stuff belongs into the clients, because they all have their own view on, for example, an order. They might be, well, the fulfillment part of an order is very different from the billing part of an order. So I've just moved the stuff that used to be in the order service to the place where it belongs, to that particular service that actually does something useful with it. And then you'll have maybe some of that stuff there, maybe it'll even disappear completely, which is kind of perfect. Because as soon as you have something that's called an entity service, you've introduced some sort of layering. I could have made that an anti-pattern, I decided not to. But the layering is, the key point of a layer is that it cuts through your business logic. And one of the key ideas in my view of microservices is to have that business logic contained in one particular place so that you can change it independently from the others. So, very often you have those service boundaries that cross entity or that are aligned with entity boundaries, and those entities are very often way too fat. It's a very, obvious, or you could call it naive approach to domain modeling that often leads to you ending up this way. So you have to think a little bit more about this whole thing. Actually, if you want to go all academic, you can view it as a violation of the interface segregation principle, which is it's one of the solid principles. It's actually a principle that says, don't make your interface too wide because then many people will depend on that interface. It's exactly what we did with an entity service, right? It had a wide interface because it has like 200 attributes on order, because now everybody can depend on it, which is a very bad idea. And again, bottlenecks. Somewhat related to that is the next anti-pattern, which I like to call anemic service, right? It's not 100% the same thing, but it's pretty close. If you look at the typical layering, that would be some sort of layered application, then you could decide to have your service boundaries at the the lowest layer, right? That would be like having JDBC in disguise. It's like giving everybody access to your data just directly. If you actually give everybody access to your data, then I don't know, at least be smart and call it a data lake or something, but if you actually do that as a service boundary, then it's probably not a very good idea. That was a joke, by the way, don't quote me on the data lake part. So, in the same way that you wouldn't give everybody access to your database, you shouldn't be giving them a service that allows them to do the same stuff. And most people agree that this is not a good abstraction. You don't want to just wrap your database table or a collection in a service. Many people do something on this level, though. They build something that's reusable, but still very low level. It's on this order service level, right? It could be something else, could be a collection of related things, but it still doesn't do anything that's useful to the actual end user. It does something that only makes sense if it's orchestrated, if it's composed, if it's used in some meaningful way. And my ideal service would sit on top of that. It would actually be a useful and specific service. This is sort of a relation, we'll get to that here, between reusability and uselessness, right? Because if it doesn't do very much, it's reusable in many circumstances. So I'd rather have something that is very, very useful, but only in one particular circumstance. That's fine with me. I don't care much for reuse anymore. Okay, so I'm not going to read all of that. It maximizes reuse at the cost of having uselessness. And it's related to this pattern of overgeneralizing, right? So if you take a look at naive object modeling, then many people come up with objects that are way too generic. It's like all those, probably everybody who really got into object orientation at one point in time or other started building some sort of generic thing machine, you know, something that's really cool. If it can do everything for every kind of entity. There's a sort of a sliding thing here. You can start with something that's obviously very useful, like say you build a service that does some aspect of your invoice handling, and you have another one that does some direct marketing stuff, and those are very, very different, and they clearly have purpose and meaning, and you build useful services, and there's nothing wrong with that. Now, if you look at them, you might notice that both the invoice handling and the direct marketing have something to do with email, right? So maybe you extract that email part which still I think is a useful idea. Meaning sending email could be done different ways. Maybe there's a general abstraction here. Maybe you could extract something like templating, where you can combine a form letter with some net data to do a mail merge kind of thing, and then send. That could be done in both, maybe, right? So, yeah, okay. Printing, I don't know. Do I want a printing service? I have a feeling my operating system already has a printing service. I'm not 100%. Maybe, yeah. What about a spell checker? Now imagine this little red squiggly line that underlines the words that you've misspelled. Do you want to have every keystroke go hit a service somewhere and come back with a? Yeah, I don't know. Maybe I'd rather have something give me the dictionary back, and then I'll use it locally because that sounds more reasonable. I don't know. You can see it's a slippery slope, right? You start with very useful things that make sense, and then you get to the stuff where you maybe have something like a hash table. Right? Sure, you can have a hash table service where you maintain all. I don't know. Maybe it exists. Maybe it's called Redis or Cassandra. I mean, you could. But if we go to this level, like we have now, we concatenate a string, and that's, at some point in time it becomes ridiculous. And this, as I said, sometimes it's more useful to have build something locally, and you just use that as opposed to trying to come up with all of this fancy service stuff. Again, I'm going to skip over the textual description here. Another thing, this is more of an organizational kind of thing, the domain last approach. This is something that I notice in many organizations where you have these structures of having business units, and you have all the developers, and then you have different groups for different aspects of your systems, right? Where essentially all of the organization is modeled in a layered fashion, right? It's like, we're not. It's not as if the domain structure of the individual business units are the driving factor. It's more like, well, everybody who knows how to program, they'll obviously go into one group because who knows how to deal with those programmer people. So let's just have some lead programmer, and then they'll do whatever they do. I don't know. But in the end, you end up with the same problem that I had before, right? You have those different stakeholders interested in things that require collaboration between these different units, and they'll actually compete about the same. Well, I hate the word, but the same resources, right? They'll compete about the same people, about the same capacity. Now, if this were cut in a different way, then they might be actually able to accomplish something. This way, they're mostly going to spend their time in meetings. So yeah, maybe don't do that. That's an ideal. And of course, this is a nice way for me to move over to patterns, right? I've spoiled your day by all of the negative things, so let's talk about some positive things. So my first pattern directly addresses the one that I just talked about, which is this idea of aligning the organization with the actual needs of delivering something digitally. If all of this computer stuff becomes important, if people who know how to work with computers are now no longer stupid people we rather not have, if digitization is actually something that we want to do, then maybe we want to align our organization so that they can actually deliver something locally. Maybe ideally we'd like to have our systems or system boundaries match that. Right? This idea of having this autonomous cell, that's what I like to call it, this autonomous unit that can actually deliver business value on its own seems extremely powerful to me. It's not a new idea. If you read up on this Werner Vogel's interview from like a decade ago, essentially this is exactly the idea, that you have this team responsible for delivering business value to a client, and if they do it manually or if they do it using some technology, it's their decision, right? They're in the position to make that decision. That I think is the most empowering idea. I find it way more empowering than getting to use my favorite programming language, because in this way I actually know why I'm doing things. I'm not only motivated by with which tools I do it, I'm motivated by what the result is that I provide. I think that's something shared by most people. Now, of course, if you look at the difference between those models, right, then I'm very well aware that this is the default in basically every large organization, especially if it's older than like 10 years, right? But you can see some new things starting up that actually look this way, right? This autonomous cell way in new and modern companies, and you can see many existing companies moving towards something like this, biz DevOps or whatever you want to call it model. Okay. Now, I promised that I wanted to move to the sizing part of things, and that's actually one of a whole separate section, because I think it's a very important thing, and I think we need to have more discussions about this. And that's actually one of the things that has driven me crazy about this whole movement for a long time now, which is that the name is so stupid. I mean, the microservices name, right? Does everybody agree that microservice is a really stupid name? I don't know who came up with it. I think it's really sad, because it makes something that is just one aspect a key part of the whole thing. I would have loved a different term, but it's too late for that, so we'll have to stick with it. So many of my sizing patterns are sizing patterns for things that you cannot really call microservices anymore, but I don't care and do it anyway. So I want to start with an example. Let's start with this slightly contrived example of a set of collaborating services that compute a value, right? These services in my example here compute a price. It's a price for something that you maybe want to sell online. And then all of these services are responsible for just providing one little aspect of the whole calculation. So one thing, we'll take a look at the weather, and if it rains, apply a special rain discount. And another one, we'll take a look at the client ID and check whether the client is some table that makes them an A client, and then reduce the price by 5%, whatever, right? Each of those little services, just one tiny thing, and they all collaborate and maybe do it in async fashion using some sort of very lightweight event bus infrastructure. I'm not talking about an ESB monster. I'm talking about some high-speed in-memory kind of thing that connects all of those things. And maybe you have 2,000 little calls of something where all the state is passed and you get something back. I like to call that FaaS, not my invention. That would actually be a function as a service model, right? Where each of those things is super small and stateless, just a function. Now, if you look at that, you could argue that this is actually the only thing that merits the name microservice, because it's really micro. But micro is typically associated with something else, so we'll have to call it nano, or, as I did here, function as a service, whatever. Typically, oversimplifying here, triggered by some sort of event that may lead to other events, that may trigger other functions, that may compute something and put it somewhere, maybe on some event queue. And then you have these very few things, ideally written in a fancy language that allows you to get things done with 2 lines of code, as opposed to Java, whatever. It's not as bad anymore. So this is actually something that somebody I respect a lot, Fred George, has been talking about even at this conference, this very, very tiny kind of thing. You can see the same approach in AWS Lambda, in all of the serverless frameworks, where essentially you have these very, very small collaborating things. If I want to put a negative spin on it, I call them Oracle database triggers in the cool version, but whatever. Now, the consequences here are all of these things collaborate to give you something, right? They share a strong dependency. Could be the AWS infrastructure, could be your event bus and your contract here is you may have the same interface used multiple times to invoke different services, maybe through some sort of eventing mechanism. You could say it's maybe you can map it to actors or something, but I'm not going to go into that. You could talk about emerging behavior, or if you want to spin it negatively, what the hell just happened? Just because if you think of it, this is all just events occurring, and then some other event is occurring, and then some event handler is being called that maybe creates an event somewhere or does something that creates an event, whatever. Something appears out of the blue, and that's kind of cool. Actually, I think this is. I'm probably painting this in way too bad a light. That probably doesn't do it justice, and I'm freely admit that I don't have much experience with this model. I'm kind of skeptical about its usefulness, even though I think it's really, really cool. One of the things that Fred applies it to and has talked about very, very convincingly is this application to fuzzy problems, where you have a limited time window of maybe like 100 milliseconds, where you can have multiple engines competing about contributing what the right extra offer to show you with your flight booking is, right? And then they all compete, and then somebody wins, and you get something, and then if the outcome is more bookings of that service, then it has been worth it. Well, maybe not for you, but for the company providing you with that service, right? So that's kind of a cool approach. It's I think a pretty rarely applied approach, but maybe it's going to become more ubiquitous with the serverless movement, and it's, I think, well suited to particular kind of problems. Now, the second example is this one. Now we're talking about, my example, a product detail page. It could be some e-commerce setup where you have a bunch of services that provide you with different things, with maybe different kinds of information. Like in my example here, the core product data, and then maybe you get some description and some images and related content and some recommendations, whatever it is that make up your information that you need for that product details page. And maybe you have some composition going on here, some service that calls a service, that calls another service, that the result is mixed together, and then you orchestrate the whole thing together to build up this composite page that includes all of this information from all of the different places. Right. I like to call that a micro-SOA. That's sort of the microservices, services-oriented architecture, which is kind of stupid, but I think it sort of captures the fact that it's very similar to an approach that used to be popular a while ago. And that's, I think, the most well-known, the most widely used version of microservices. I'm happy to be proven wrong here, and I'd love to discuss with you about this. The idea here is those things are small and self-hosted. They're not micro. They're maybe not a few dozen lines of code. They're more like a few hundred or a few thousand lines of code. They're still small. They typically are containerized, because everything is containerized these days. They typically have this cascading, this streaming model where you use some technology to make it easy for you to maybe talk to 3 services and get the results and merge them together and start delivering the result to your upstream caller before all your incoming results are there. So you build these things, and that's probably most or best known because Netflix is a big advocate of this approach. There are others as well. You can find numerous examples of this. Now, this is really hard for me to explain, but I have a very ambiguous relationship with Netflix. I love the company. I'm a very satisfied customer. I spend basically all of my TV time in front of Netflix. I also love their tech, and I love the people that they have talking about it. They're super, super smart, amazing people. They're also completely useless as a role model for most of you and most of us, because most of us are not in the business of building a video streaming portal. It would be cool if we were, but we're not. most of the time at least. Maybe some of you are. And now my statement, my claim is that Netflix's architecture works extremely well for Netflix, but that does not mean it works for anybody else. You really have to look at the individual situations. If that is your role model for your microservices architecture, I claim there's a high chance it's going to fail. I'm not a big fan of this model. I think it has a huge number of positive aspects, but it also has some downsides, and you should be aware of what you're doing here. Now, some of the consequences are you have this close collaboration, you have this idea of a common goal, you want to deliver a service. In my example, it was this product details page. That's something that's assembled from all of those services. But because you have now services that call services, you need to deal with the complexity and with the risk to the stability, which is why you introduce fancy patterns or resilience patterns to address all of this stuff. You also have wonderful problems regarding versioning and compatibility, because you now have this network of complex services all calling each other, where if you multiply that with all of the versions of the thing that you have to keep in existence, makes it a really complex thing, which leads to a superbly high infrastructure demand. You really have to have a very, very cool environment to be able to do that. And if you're in the business of building very cool environments, that's kind of a very satisfying proposition I'm building here. It's often combined with all this parallel and streaming kind of stuff. And to also make very clear why I think this is sometimes an excellent idea, I think it's really well suited if you have extreme scalability requirements. If that's your major factor, if that is the reason why you're doing microservices for runtime scalability, then I think this is a very cool model. Now, in my experience, that may be selection bias, because we see certain clients, certain people that work with us. In my experience, the reasons for many people, doing microservice for many people are different. Very often, they have something like this. They have some complex business application, maybe a logistics application, that's composed of different parts. And now they start noticing that they have all of these annoying meetings with people who want other things, and it's kind of I don't want to have meetings, I want to build cool software. So I start building those isolated places where I can actually do something on my own without having to deal with too many people at the same time. So I end up having those things where I accept some redundancy, I maybe have some sort of eventing mechanism, and I actually make sure that I have isolated parts. That actually leads me to something which in the DDD world is called a bounded context, and if I combine that with microservices, I get the DDD pattern, which is distributed domain-driven design. I like that term. And that's the next pattern. Now, I think oh yeah, I had to mention one thing. One nice thing here, or one important aspect here, is that there is a separate front end, right? I've made a point of putting that there. So it's really talking about backend services with a front end that combines all of that stuff, and now we have those individual contexts. The idea here being that each of those things is still small, but probably a little bigger. But most importantly, it can do its own thing on its own. It doesn't rely on synchronously calling to other services. Communication between those things typically occurs asynchronously, right, by events. And the front-end calls, if you recall, the front-end calls that go in, they typically stay within one of those things. Yeah, hopefully. Right? So we end up with redundancy. We end up having to manage that redundancy, but what we gain is more autonomy, more independence of those individual units. Right? You accept that you have to store something redundantly, and then you actually implement some logic redundantly. There are a number of clients, I can't talk about ours who do that, but I'm sure you know many who do that. If you have some public examples for me, I'd be happy to add them to the slide. I think this is really a different way of approaching the whole thing. Many people do this. I'm not claiming this is exotic or anything. Many people do it this way. They use bounded context, and they make every service at most as big as a bounded context, and at least as big as an aggregate, and then you end up with a reasonable sized, bigger kind of thing that can do its own stuff. Now, this is, I think, the first one where you explicitly want to manage loose coupling at the level of the whole. You're really trying to get those things to a size where they become autonomous units of their own. I think it acknowledges this separate evolution. It's really a different motivation. The key motivation is not scalability. It's trying to come up with those boundaries between groups. The async approach increases stability of the whole things because you don't have these call stacks of remote services calling each other. And I think it advocates and emphasizes parallel development. Right. So I'm a bigger fan of this, and I've seen it applied successfully a number of times now. If only there weren't this one thing that I'm always so annoyed about. In fact, 2 years ago I did a talk here about that easy UI thing. I don't know whether any of you were here. But there's always this assumption, this typical back-end architect assumption, that the front-end part is the easy part. Right. Yeah, it's not. That's the assumption, that's reality. The front-end part is not at all easy. In fact, I think the front-end part is the harder part. It's the more important part. It's the part we shouldn't be ignoring, but many of us are ignoring it. And I've actually turned it into a anti-pattern of its own. It's the front-end monolith, right? You have this fancy back-end microservices architecture fronted by a front-end monolith. Now, if that front-end monolith is built by 1 or 2 people, I'm fine. I don't think you should split something in a microservices that can be built by 2 people. But typically, it's not. Typically, in a large system, you have a dozen people working on that front-end monolith with all of the downsides that monoliths have. I'm not going to go through all of them, but very briefly, you end up with something that has all of the downsides of a back-end monolith. It has over-reliance on one particular framework from one particular vendor, and just because that vendor is very famous and because everybody knows them does not at all mean that their framework is going to be there 2 years from now. Even if it has the same name and just a different version number, it might end up being a completely different framework. So maybe don't depend on that in the same way you no longer want to depend on back-end frameworks. Which leads me to my final size example, and if you've seen some of my colleagues' talks, you'd probably know where this leads to. My example here is an e-commerce site. Now you can see that I've added this part down here, which is actually supposed to be the front-end part. Now, if you look at an e-commerce thing at a larger scale, then you're not looking at the product details page, but rather at the next level, you can see different sort of vertical slices through the application, maybe the part where you register and maintain your account, and maybe the part where you browse the catalog, and then maybe the part where you check out. And actually, each of those parts can have their own front end, and the front ends can be connected. Right? The idea here is that I do front end integration and have maybe a link to a different system integrated here, or maybe I have something embedded from one of the other systems. We call this pattern self-contained systems, and it's essentially the next level in size. Right? It's a little bigger because it now includes the UI part. Otherwise, it's very similar to the DDD part that I talked about a few moments ago. It has UI and DB, and it's possibly composed, but I'll get to that in a second. You can also see a number of examples of that. I claim that Amazon does something like this. I may be wrong, because of course they don't use the word. But I think you can notice it some points in time when you go through Amazon.com's website and you go from one part to the other, you can notice that the UI changes somehow. I'm not talking about the AWS mess. I'm talking about the e-commerce part, right? Where you go from looking at the product to the checkout part, where it's sometimes at some point in time it seemed a little more modern, because I think it was built a few years later in the other part. I think that's an instance of this model. There are a number of other companies, and we also have built a website there. It's a public website where you can contribute. It's not copyrighted or associated with any product of any kind. It's just the idea of building things this way. Now we have larger systems, independent systems, including data and UI. We're able to autonomously serve the requests that come in, and we have this lightweight integration, typically front-end part, no need for the fancy stuff. We can augment that and add some eventing to it, which makes sense because of the redundancies, but it's not the key part. It's not as if they all communicate using events all the time, so you don't need any extra infrastructure. And I claim it's the best suited model. It's extremely well suited if your goal is to separate development teams. But if that's what you want to do, then that could be a very useful model for you to apply. Now, I've given you 4 different sizing patterns, but of course, first of all, this was extremely simplified because there are lots of gray areas between those models, right? But I can't do 15 patterns, so I'm just doing a limited number. And more importantly, possibly, you can actually combine them. Now that's a good excuse to get that beautiful fractal in there. But essentially what I'm trying to say is that you can have a building block that's built of building blocks that are built of building blocks. So in that model that I just talked about, you could have a self-contained system or a number of self-contained systems, and then those self-contained systems systems could be composed of the next level. Maybe some of them are built in the Netflix-style Microservice-SOA approach, and another one is built maybe in the serverless style. Essentially, you can make that decision on with every single box. You don't have to do it the same way in all of them. You don't have to have the same hierarchy at each level. You can start by splitting something into 5 of the big ones, and then one of them is complex enough or maybe has scalability requirements that make you turn it into something smaller. Now, why I'm going on so much about the size thing, I have the strong feeling that if your only structuring mechanism is one of the smaller ones, you know, the serverless part, the function as a service part, or the Microservice-SOA part, that's going to be tough. If you're looking at an architecture that's composed of 2,000 things that are sit next to each other, it's going to be hard to understand. So I'm advocating of having a little more structure on top of that. I'm not suggesting big upfront design, I'm just saying, you know, group things a little, cluster them. I have a final pattern that I think gets lost sometimes. Maybe we're mature enough to not have it lost all the time. The final pattern, of course, is the monolith. Right? Because if you look at the size thing that I did, I started with the smallest, with the finest granularity. If you compose a system into just functions, that's going to be a lot of functions if the system is big. And then I made the pieces bigger, so we have fewer and fewer pieces, until at the very end we just have one in this discussion, which is maybe just perfectly fine for certain scenarios. Why? Because a monolith has benefits. A monolith is highly integrated, very cohesive. You can load it into your IDE, you can look at it. As long as you can handle it, it's really, really nice. It's a standard application, internal monolith, blah, blah, blah. You can probably think of this. I think it's ideally suited for many cases still. Again, I don't think anybody really claims that everybody should use microservices for everything all the time, but I still think it's worth pointing out that a monolith sometimes is a good idea. And if you think of the approach of taking a look at a big system and maybe splitting it into few big parts, like maybe 7 or 10 parts, then maybe 2 or 3 of them are best built as a monolith. Right, and maybe the 7 others are built in a different way. So maybe if we love monoliths so much, we should build many of them. Right? So if they're good monoliths, then we're happy with them. So I'll conclude with some final recommendations, and the risk here is that they really sound like absolutely applicable to every presentation I'm ever going to deliver, which is fine with me. So the first one is this. I think that is a common statement. You can put it into any slide deck, and it's very true in this particular thing here. None of those things is the right one, right? Not serverless, not the Netflix style, not the DDD style, not the monolith, not the SCS thing. All of them very much depend on context. And you should never feel forced by a solution to apply it. It should always be driven by the problem, by the domain, by the business benefits that you're looking for. Sometimes those benefits are come from an architectural perspective. It's actually an architectural concern that you have. And that's fine. Like, for example, loose coupling, right? Or parallel development or parallelizability of development, right? So you have to look at that. If scalability is your #1 requirement, you'll end up with a different architecture than when separation of development teams is your key requirement, or maybe even the frequency, the high frequency of release is your main intended benefit. So take a very close look at that and then choose the matching solution. Pick the one that matches your needs. And finally, what's true for individual services is also true for the whole thing. If you can, in any way, then try to create something that can evolve. Don't make a decision that ties you into any particular technology or approach. Try to build an evolvable, evolutionary architecture that can actually grow as you and your requirements grow. And that's essentially all I have. Thanks a lot.
Thank you.
Do we have time for questions?
Yeah, we have about 5 minutes for questions, and we have a longer break behind after that. So, are there any questions?
There?
I see one there, on the last edge of the room.
First of all, thank you very much for the talk.
You're welcome.
Very nice. Do you think there is a chance in the future that we are going to come back to Monolith again? because if you will think now, we complain a lot about enterprise service bus, and then comes service mesh, which is the solution for communication between microservices. So we have, for example, some companies having a monorepo, and do you think there is a chance for that?
I don't think we'll ever get back to the bad times we had in the past, because they were bad times and nobody wants them back for very good reasons. I don't think anybody still wants to build a monolith with 25 million lines of code. Most people would probably agree they don't want to have a monolith with 2.5 million lines of code. Maybe we'll move from trying to build stuff that has 1,000 lines to something that can accommodate 10,000 or 20,000. So, you know, it's like a pendulum that swings a little bit. So I think it's going to become a little less fine granular. We're going to move to somewhat larger systems. I don't think we'll ever get back into the monstrosities that we had in the past, where you had like 100 people working for 5 years and then releasing something in a big bang fashion that failed. That's not something anybody wants to do again.
Yes. Any other questions?
Disagreements, fine with that as well.
Yeah, discussions.
Well, actually, I have one.
There.
Chris, please pass him the mic.
Well, since my talk had an order service, I feel...
So sorry.
I feel personally attacked.
Mission accomplished.
No, actually, I tweeted this. So one of the problems with like saying like entity service is an anti-pattern is then it gets into the definition of what an entity service is, right?
Of course.
And so sometimes just calling something entity service is, to me, a perfectly good, decent name, right? Even though the functionality that it's implementing, like in the case of my order service, it's got kind of like high-level operations like place order, revise order, cancel order, right? And it's support, you know, and it's specifically supporting what a consumer would do who's interacting with the online store. I don't know, maybe my naming is sort of unimaginative, and if you have a better one, tell me quick, because then I'll do a global search and replace on my book. But that to me is okay, and especially in my context where I specifically designed my order aggregate to be in my opinion, right-sized. And in fact, what was previously a bloated aggregate is split across the delivery service that's handling some aspects of fulfillment, the accounting service, and so on. So it's sort of like, kind of, but it's sort of like, what do you really mean by an entity service?
Yeah. So I sort of feel unfairly attacked by the nuance that you bring to this discussion, right? I mean, this is all very much oversimplified. If I'm saying an entity service is bad, of course, you're right to ask what I mean by entity service. So some observations. The first thing is that when we talk about examples, then they're very often simpler than real-world systems. So it may be perfectly fine in an example scenario. It's probably not going to be fine in a real-world scenario where you end up with an entity service that has, I don't know, has too much responsibility. I'm pretty sure you would agree with that. If everybody keeps hitting that thing, if you have very conflicting requirements for that thing all of the time, then probably it's a sign that it's really not one thing, it should be multiple things. That it's an entity service is probably a smell. It's something that makes me look very closely at it. If it's well designed, as I'm sure yours is, then it's perfectly fine. But I've often seen that it's not. Often it's just, you know, people use patterns and use approaches that they know, and, you know, doing a data modeling kind of thing is something that people know, especially if you're starting out. It's very easy. You can just talk to 5 people, and then you come up with this thing, and you draw this little model, and then you turn everything into a service, and I've seen it lead to disaster. So you maybe just be careful what you're doing here, and that's probably something we can agree on.
Yes, yeah.
Okay, he said yes, I have to. He doesn't have the mic, so I have control.
Mike again, yeah.
Yeah, I mean, the other point is maybe the underlying anti-pattern is like blob I mean, actually, in the classic Antipatterns book, there was the blob, right?
Yeah, probably.
And it's kind of like the blob aggregate that just sucks up all this functionality. Might be more of the underlying problem.
You may be right. Yes, I'm really thinking about those database tables that have like 300 columns in your RDBMS, right? Where everybody who wants to store something with that thing adds another column to the monstrosity table that everybody's afraid of touching.
Yes. So I think of blob, or actually,
It's
blob
okay.
classes, actually.
Any other comment?
Over there. In between, this is a great warm-up for the panel, which will happen.
Oh yeah,
at
we'll have a
7.
panel later.
You mentioned the micro platform as a anti-pattern.
Yeah.
What we can see now that there are some products arriving like Linkerd, Istio, and so on, which take over some common functionality like to have service discovery and so on for building a service mesh. Is this the wrong way? Is the sidecar's idea, or is it just better to put it into the infrastructure?
Well, I'm really undecided. I think there's a risk in there, right? I think what I actually wanted to address was more the stuff within your service, right? You're like these sort of, everybody assumes that everyone's using Java anyway, so let's just build this useful Java library that anybody can use, and then a few years later you discover, oh, I'd like to try out Go, and then you come up with a crazy idea like, containers sitting as to the side or whatever, right? So I think this is the stuff that I wanted to address, but the point you address is also very valid, I think. This adopting a product on the macro level between your services is a very useful thing, but it's also a very risky thing, right? The more common that product is, the less of a dependency you have on it. And that's true for everything. It's true for your cloud provider, it's true for your service mesh, it's true for Kubernetes, right? Do you want to depend on it or not? So you really have to make this cost-value analysis. I'm not saying it's wrong all the time. We use lots of stuff all the time because it's useful to us, and I think that's a good approach. Just have to manage it and be very aware of the sort of lock-in that you accept with that.
Okay. I would suggest one more question if there's one.
Yeah, if there is one.
Okay.
Cool.
Thanks a lot.
This was fun. Thanks.